So hello and welcome back. In this video I would like to do basically a second part of this video, which is about another way to solve those equations algebraically, which is called the cross multiplication method. So this method is also useful in many kinds of situations, and it's called the cross multiplication method. And what that is that basically if you have something like basically two linear equations in two variables, meaning that if you have a1, for example, x plus b1 y plus c1 is equal to 0, and a2 x plus b2 y plus c2 is equal to 0. Let's say that this is a pair of linear equations in two variables. Okay, now suppose that you want to solve this system of linear equations. So what you would do is that somehow you have to get rid of one of your variables, basically in the method of elimination that we had before. What we did was that, for example, let's say that you have let me give you an example. So let's say that you have, for example, the cost of for example 5 oranges and 3 apples is for example I don't know, $35. Is $35, okay? And also the cost of 2 oranges and 4 apples is $28. Okay, so how would you solve this problem? So what you would do first, you would have to basically have two algebraic equations for in this form for this kind of situation. And if I take, for example, oranges by x, the cost of an orange, take the cost of 1 orange by x, and the cost of 1 apple by y, then what you would have is that the cost of 1 orange is x, and the cost of 1 orange is y. So 5 oranges would be 5x, and 3 apples would be 3y is equal to $35, and then 2 oranges would be 2x, and 4 apples would be 4y is equal to $28. And that would be basically a pair of linear equations in two variables that you could solve in order to get to the cost of 1 orange and 1 apple, basically. Okay, so that is that. Now, of course, you can write this in general form, meaning that you can write it as, for example, you can write it as 5x plus 3y minus 35 is equal to 0, and then 2x plus 4y minus 28 is equal to 0, and then you would be able to solve this equation by for example, if you went for the method of elimination, you would basically get the, if you call this equation number 1 and if you call this equation number 2, basically you would, for example, multiply equation number 1 by, for example, a factor of 4, meaning that I want to get rid of my y's, for example. If I want to get rid of my y's, I multiply equation number 1 by 4 over here, and equation number 2 by 3 over here. Okay, so equation number 1 multiplied by 4 would be 5 times 4 times x plus 3 times 4 times y minus 35 times 4 is equal to 0. Call it equation number 3, for example. And then equation number 2 multiplied by 3 would be 2 times 3 times x plus 4 times 3 times y minus 28 times 3 is going to give me a 0, number 4. And then if I basically subtract, for example, 4 from 3, if I subtract 4 from 3, what I would get is basically 5 times 4 times x minus 2 times 3 times x plus, I'm subtracting 4 from 3, so 3 times 4 times y minus 4 times 3 times y, 4 times 3 times y minus 35 times 4 minus negative of, basically minus negative 28 times 3 would be plus 28 times 3 is equal to 0. So this is subtracting basically 4 from 3. Okay, and then 3 times 4 times y, 4 times 3 times y, these two would cancel out, and then you would have 5 times 4 times x minus 2 times 3 times x minus 35 times 4 plus 28 times 3 is equal to 0. Then you can take then x out, 5 times 4 minus 2 times 3, and is equal to, you can take this to the other side of the equation, 35 times 4 minus 28 times 3, and then your x would be equal to this whole thing, 35 times 4 minus 28 times 3 over this whole thing, 5 times 4 minus 2 times 3. Okay, so what that means is that over here, if I take the basically a1 is equal to 5 here, b1 is equal to 3 here, and c1 is equal to negative 35, and then a2 is equal to 2 there, b2 is equal to 4, and c2 is equal to negative 28. So what I've gotten here as x is, I can write it as basically 35 times 4, so that is b2 times c1, so b2 times c1, but the negative of that, And then here I have 28 times 3, which is I have negative 28 times 3, so 28 times 3 would be B1 times C2. B1 times C2. Okay, B1 times C2 would be negative 28 times 3. And then in the denominator I have 5 times 4, which is equal to A1 times B2. A1 times B2, A1 times 5 times 4, 2 times 3 would be minus A2 times B1, okay, and then I can rearrange this. I can write it as, for example, B1 times C2, B1 C2 minus B2 C1 over A1 B2 minus A2 B1. So that is basically how you could basically get to your x. And you can use this formula for any kind of pair of linear equation in two variables. So I guess I've written them somewhere over there, but it's not important right now. So that's basically how you would solve this kind of problem. So now instead of playing with basically this particular situation, you can actually go and solve a general case for this. Meaning that let's say that you have two linear equations in two variables, and I have a pair of linear equations in two variables. Let's say that it's a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Let's say that this is a pair of linear equations in two variables. So as you saw over there, in order to get my y's, if I call this equation number 1 and if I call this equation number 2, I multiplied equation number 1 by the coefficient of y in equation number 2. By B2, and then I multiplied equation number 2 by the coefficient of y in equation number 1, so by B1. Okay, so if I do that, I will get basically equation number 1 by B2, so a1 b2 times x plus b1 b2 times y plus b2 c1 is equal to 0, and then multiply equation number 2 by b1, so a2 b1 times x plus b1 b2 times y plus b1 c2 is equal to 0. And then let's call this, for example, 3 and 4. And then what you can do, you can, for example, subtract 4 from 3. Okay, so then you would have a1 b2. In order to subtract, what you can do is that you can take the algebraic opposite of this, of every term in 4. So in order to subtract 4 from 3, you can take the algebraic opposite of every term in 4, meaning negative, negative, and negative, and then add them together. So you would get a1 b2 times x minus a2 b1 times x, and then b1 b2 plus b1 b2 times y minus b1 b2 times y plus b2 c1 minus b1 c2 is equal to 0. And you see you have b1 c2 times y, b1 c2 times y, so you can cancel them out. And then you have these two terms that contain x, and these two are constant terms. So you can take the x out from these two equations, from these two terms. a1 b2 minus a2 b1 is equal to, so then you can take these to the other side of the equation, meaning that b1 c2 minus b2 c1. And then you can write your x as this whole expression, b1 c2 minus b2 c1 over this whole expression, a1 b2 minus a2 b1. Okay, so that would be your x. And that's basically how you solve for your x. Now you saw that in order to solve for x, I had to get rid of my y in order to get to x. So you can now get rid of your x's in order to solve for y. Okay, so I'm going to write this thing over here again. So I had a1 x plus b1 y plus c1 is equal to 0, and a2 x plus b2 y plus c2 is equal to 0. The same pair of linear equations. Now here I got my x, now I need my y. So I want to get rid of my x's. So in order to get rid of my x's, I'm going to multiply equation number 1 by the coefficient of x in equation number 2, which is a2, and then multiply equation number 2 by the coefficient of x is in equation number 1, which is a1. Okay, so now multiplying equation number 1 by a2, so a1 a2 times x plus a2 b1 times y plus a2 c1 is equal to 0, and multiplying equation number 2 by a1, so a1 a2 times x plus a1 b2 times y plus a1 c2 is equal to 0. Okay, and now I can call this, for example, 3 and 4, and then subtract 4, for example, from 3 in order to get rid of these two terms, for example. So I can take the algebraic opposite of these terms and then add these together. So that would give me a1 a2 times x minus a1 a2 times x plus a2 b1 times y minus a1 b2 times y plus a2 c1 minus a1 c2 is equal to 0. And then you can, this is a1 a2 minus a1 a2 times x, so you can cancel these two out, and then you can take the y out of these two terms, so a2 b1 minus a1 b2, and then you can take these two terms to the other side of the equation. Okay, so you will have a1 c2 A1C2 minus A2C1. So your y is going to be equal to this whole expression, A1C2 minus A2C1 over this whole expression, A2B1 minus A1B2. Okay, so that's going to be your y. Now let me write down these two things on a notepad or something. Not notepad, I'm sorry. Not notepad, but paint. Okay, so my x was this thing over here. So x is equal to B1C2 minus B2C1 over A1B2 minus A2B1, and my y was equal to A1C2 minus A2C1 over A2B1 minus A1B2. Okay, so now in order to basically make things a little bit easier, and more consistent, you see over here in the denominator I have A1B2 minus A2B1, and here I have A2B1 minus A1B2, exactly the algebraic opposite of this expression, or algebraic opposite of this expression over here. So I want to have the same denominators. So what I will do is B1C2 A2C1 A1B2. Okay, so what I can do here is that I can multiply both the numerator and the denominator of y by a -1. So -1 over here and -1 over here. So what I will get is I will get A2C1 minus A1C2, and in the denominator I'll get A1B2 minus A2B1. Okay, so now you see my denominators are the same, A1B2 minus A2B1, A1B2 minus A2B1. So, and then what you can do, you see that if I write this thing over here, this x over here, if I cross multiply, if you imagine that there is a 1 over here, so you can cross multiply this way, and you can cross multiply this way. This will be x times A1B2 minus A2B1 is equal to B1C2 minus B2C1. Okay, and then x over, basically if you divide basically x by this term over this whole expression over here, divide x by of course what I'm doing here is going to make sense to you when we get to the end of it, but 1 over A1B2 A2B1. Okay, so you know that if you want to calculate, for example, this term over here, so a1b2 minus a2b1 is going to be equal to this whole expression b1c2 minus b2c1 over x. And if I take the reciprocal of this side of this expression, take the reciprocal of this 1 over a1b2 minus a2b1, take the reciprocal of the other side as well, x over b1c2 minus b2c1. So that's basically one of the things that I can use over here. Okay. Now what I'm going to do is that I'm going to do the same thing for y as well. I'm going to do the same thing for y as well. So I know that my y is equal to this whole thing over here. So a2c1 minus a1c2, a1b2 minus a2b1, and cross multiply, you will get y times a1b2 minus a2b1 is equal to a2c1 minus a1c2. And then if you want to calculate this expression over here, you will get a1b2 minus a2b1 is equal to this whole expression a2c1 minus a1c2 over y. Take the reciprocal of both sides, you will get 1 over a1b2 minus a2b1 is equal to the reciprocal of this side, which is y over a2c1 minus a1c2. And that's another thing that I can use here. So now if you take a look at what we've gotten over here, is that you see over here is 1 over a1b2 minus a2b1, 1 over a1b2 minus a2b1. So basically that means that this side of these two equations are equal. So I can write x over b1c2 minus b2c1 is equal to y over a2c1 minus a1c2, and that is equal to 1 over a1b2 minus a2b1. And that's basically the relationship between x and y and all of the coefficients that we have over here. So I write this down over here. I write it down over here as x over b1c2 minus b2c1 is equal to y over a2c1 minus a1c2 is equal to 1 over a1b2 over a2b1 minus a2b1. Now let me check whether this thing is actually correct, and then I'll also show you a way in order to remember this thing. X over b1c2 minus b2c1, a2c1 minus a1c2, 1 over a1b2 a2b1. Okay, so this is correct. Now the way that you can remember, that you can actually memorize this thing, is that you can write here x, y, and 1, meaning that x, y, and 1 are the numerators here, and then here you have b. Here you will have b1, c2. Here you'll have b and c. Here you'll have b and c, and here you have C and A, BCA, and here you have B over here. Here you have B over here, so BCAB, right? Now I'll tell you what I mean by this. So here you write B1 and B2. Here you write here you write C1 and C2. So B, B1, B2, C, C1, C2, A, A1, A2, and B again, B1, B2. And then you can cross multiply this way. Okay, so you can cross multiply this way, and what you can do is that these are your numerators. Okay, so you can write this as the numerator x, and then here b1 c2, b1 c2 minus b2 c1, which is exactly what we have over here, is equal to the numerator y over c1 a2, or basically a2 c1 minus a1 c2 is the same thing as 1 over a1 b2 minus a2 b1. And that's basically how you can solve any pair of linear equations in two variables. And that's basically why it's called cross multiplication method. Cross multiplication method. Okay. So now there is a problem over here, and that is and the problem is that if basically there is a problem over here with okay, so then there are a few cases where these denominators become 0, and there you will have a few problems there. I'll show you what you can do with that. Okay, so now there is some discussion, but before we move any forward, let me make a screenshot of here, because I might need this thing. Okay, so basically now there is you could argue that basically we said that no, not this thing. Okay, so you could argue that, so basically we said that x over basically b1 c2 minus b2 c1 is equal to y over a2 c1 minus a1 c2. Okay, and that's equal to, that's y, and that's 1 over a1 b2 minus a2 b1. Okay, so basically to calculate x, you would get basically this part over here and this part over here together. So x over, for example, b1 c2 minus b2 c1 is equal to 1 over a1 b2 minus a2 b1. And so your x is going to be equal to x over b1 c2 minus b2 c1 is equal to 1 over a1 b2 minus a2 b1. And so here basically if you cross multiply and if you want to solve for x, your x would be equal to b1c2 minus b2c1, for example, over this whole thing, a1b2 minus a2b1. Okay, and then by the same logic, basically y would be equal to a2c1 minus a1c2 over basically a1b2 minus a2b1. Okay, so this is the value of your x and y. Now you cannot use these two relationships if a1b2 minus a2b1, which is the denominator here, is equal to 0. Okay, so if that's equal to 0, I'm sorry, if it's not equal to 0, of course you can use it. If it's equal to 0, then that means that a1b2 is equal to a2b1, and then you can rearrange these. You can rearrange this equation as, for example, a1 over a2 times b2 divide both sides by a2. So a2 over a2 times b1, and then these two will cancel out. You have a1 b2 over a2 is equal to b1, and then divide by b2, both sides divide by b2, you'll get a1 b2 over a2 b2 is equal to b1 by b2, and these two will cancel out. So what that means is that a1 by a2 is equal to b1 by b2. So I'm sorry, if it's equal to 0, then you're going to have no answer or no solution. If it's not equal to 0, you will have a solution. Okay, so you will have a solution. So this is not equal, this is not equal, this is not equal, not equal, and not equal. So that means that if basically a1 to a2 is not equal to b1 to b2, then you will have a solution. You'll have a solution. Okay, and that basically fits with everything that we have done so far, because we said that basically we had all of these cases. We had these three cases where we had an intersecting pair of lines, and then here we said that basically a1 to a2 was not equal to a1 to b1 to b2, and then we had two parallel lines. In that case, we said that a1 to a2 is equal to b1 to b2, b1 to b2 is not equal to c1 to c2, and then we had two coincident lines, and in that case we said that a1 to a2 was equal to b1 to b2 was equal to c1 to c2. Okay, so over here you can see that if you have to have a solution over here, which is this point, we said that a1 to a2 is not equal to b1 to b2, and that's basically what happens here as well. a1 to a2 is not equal to b1 to b2. So at the end of the day, you will get the same kind of deal that we had before. Meaning that if a1 to a2 is not equal to b1 to b2, you will have a solution. If basically a1 to a2 is equal to b1 to b2 is not equal to c1 to c2, basically you will have no solution because the lines have no point of intersection. And if the two lines are coincident, then all the three ratios are going to be the same. And that's basically when and these two cases are basically when you have this thing over here, this denominator, that's basically when this denominator is equal to 0, then one of these two cases is going to happen, which you will know. Then you can basically go in and check your coefficients and see what's going on in your equations. We'll get to them in the exercises. Meaning, but if a1b2 minus a2b1, meaning that when you use these two formulas or equations, whatever you want to call them, if a1b2 minus a2b1 is equal to 0, if it is equal to 0, then that means that you cannot use these formulas, because you would be dividing by 0, right? So you will not basically x and y over here. And if you don't get some x and y, what that means is that either you have no solution or you have infinitely many solutions over here. That's basically what happens. So that's basically all that there is about this whole business of cross multiplication. And just to summarize it, you can remember this thing and then use the formula. So basically x over b1c2 minus b2c1, and of course you don't have to memorize this. I already showed you how to basically remember it. So a2c1 minus a1c2, and that's equal to 1 over a1b2 minus a2b1. And you can of course memorize this or remember this by, you just write the numerators x1, xy, and 1 over here. So x, y, and 1, and then here you write bca, b. So here you write bcab, I think bcab, right? So bcab, and so this would be b1 and b2, this would be c1 and c2, this would be a1 and a2, and this would be b1 and b2. And then here, this way you can cross multiply and get those, basically get these three relationships here, meaning that you can write x over, for example, b1c2 minus b2c1 is equal to y over a2c1 minus a2c1 minus a2c1 minus a1c2, and then again you can write a1b2, and then a2b1 minus a2b1, and then that's basically 1 over this, and then that's basically the formula that you can use in order to solve these equations.